Hello everyone. Let's look at today's Leetcode problem 909 Snakes and Ladders. Before starting this problem, let us look at a motivational quote for today. Keep working even when no one is watching. Success belongs to those who trust the process, believe in themselves, and never stop moving forward. Okay, so let us understand the problem statement. So, there is a pretty big problem statement for this problem, or you are given an n into n integer matrix board where cells are labeled from 1 to n square in a Bostrofiden style, starting from the bottom left of the board and alternating each row. So Bostrofiden style means left to right and right to left and left to right again. So it interchanges based on the board dimension. You start at the square one of the board. In each move starting from square current, do the following. Choose a destination square next with the label in the range current plus 1, minimum current plus 6, or, or n square. This choice simulates the result of standard six-sided dice roll, that is, there are always at most 6 destinations regardless of the size of the board. If next has a snake or ladder, you must move to the destination of the snake or ladder, otherwise, you move to next. The game ends when you reach the square n square. A board square on row and column has a snake or ladder board RC not equal to -1. The destination of that snake or ladder is board RC, R row and column. The squares 1 to n square are not the starting points of the snake or ladder. Note that you can take a snake or ladder at most once per dice if the destination to a snake or ladder is the start of another snake or ladder. You do not follow the subsequent snake or ladder. For example, suppose the board -4, -1, 4, -1, 3, and on the first move your destination square is 2. You follow the ladder to the square 3, but do not follow the subsequent ladder to 4. Okay, so this piece of statement mainly says that we can only choose one, either a single snake or a ladder. So this is clear in this piece of statement here, right? And board square row column has snake and ladder, the destination square. Okay, so another thing here is this says how we can move through the board. Return the least number of dice. Return the least number of dice rolls required to each reach the square in square. If not possible, return the square -1. Okay. Okay, so let us understand with a example here. So let's say we have a board dimension this way, where there are multiple set of values with -1, -1. So there are 6 rows and 6 values in each row. So these represent the rows and the number of rows that are rows, and number of rows will be a set of columns. So in this case we see 6 rows and 6 columns. So first item in this boards array will give the length of the rows, that is this, and the length of the columns is length of the board itself, right? Okay, so uh, we want to calculate uh, on a dice roll, or what is the best dice roll that we can take to reach the destination of 36. So we want to reach 36, but what is the most efficient way to do it with the dice roll? What is the probability? So we take a step one, so we get a roll one and we move here, which is 15, and this all happens in the same step. So we get one, we also update our current position to 15, and uh, once we are at 15, we get a dice roll of 2, which makes it to 17, and from 17, since it's a snake, we we return it back to 13, and from 13 we change it back to, if we get a dice roll of 1, and we simply move our destination node to 14 to 35, and from 14 to 35 another one would give us the end. So these are the set of dice rolls that we are expecting. So we might need to return 4 as the output. So in the beginning, the explanation here is also stating the same, where you start at square one at row 5 and column 0, and you decide to move 2 squares and must take the ladder to 15, and you decide to move to the 17 square, you must take the snake to square 13, and from 13 you then decide to move to square 14, which takes a ladder to the square 35. You then decide to move to the 36 square 36, ending the game. This is the lowest possible number of moves to reach the last square. So return 4 as the number of dice rolls. So as requested, the least number of dice rolls is what is asked, right? So okay, so let us look at an approach on how we can solve this problem. So it is clear that we know that this problem looks similar to a graph problem, where from a node we might want to find the shortest distance to a specific node, and the values that we want to evaluate is with respect to dice roll, which is from 1 to 6, and we might want to see within this what is the shortest path that we can reach the new node. So we need to find shortest path, and BFS is the best way to approach this problem, where we go in row by row. So uh, our approach might be something like, firstly we initialize a queue with the first square, and we continuously check for queue if there are new elements to the queue. But yeah, we check for the dice roll. So we check if with queue, and for dice roll of 1 to 6 we check it, and we compute the next square, also map it to the row. If row column has a snake, we move to the we check if the square has a ladder or snake, we compute that and mark all the nodes as visited. So we somehow want to reach at each stage best possibility of a node that can take us to the uh, next farthest node in the same row with the dice roll of 1 to 6. So let us go to our Leetcode editor and let us try solving this problem and let us talk through the solution. So let us understand how we can solve this problem. So we are going to have a while loop which is going to be of the check, where we are always going to check if q has a length greater than 0, and we are also going to initially q and we are going to set the starting point for the queue, and from there we are going to explore the next set of nodes for the shortest path, with each node having to return a shortest path from it to maybe the higher precedence of result that it can help us reach. We are going to add in certain conditions, like if the next square is out of the board length, then we are simply going to continue to the next node. This would be one of our boundary conditions here, and let's say we get the column and row count. Maybe we might also need to build a coordinates function which is going to take the next square to explore the shortest path, and if board row comma c is not equal to -1, or if it's still an unvisited node, then we take the value of next square and assign it to this value. we are going to add the particular square to the visited array. And we are going to push this next square to further exploration. Okay, so now let's build this function which is get coordinates, and once we do all of this we can simply return -1 if there is no possible paths that we can see. So let's build the get coordinates function. Before this we are going to define certain okay, so yeah, so get coordinates is going to be a function which is going to take in a square, and we are required to calculate or return the row and column of it, or return the specific row and column value. And note that this is a bistrophidian style where it starts from the bottom with left to right and right to left, and thereby it flips its sides, sides or direction. So so this would give us the row value, and let's similarly calculate for the call, which would be, if row from bottom is uh, an even one, then we simply can return the call from left, else we might need to do the similar thing where we go from the last and let's simply return row comma call. Okay, so this should be our solution. Let's try submitting the solution. Okay, so I also see one other boundary condition which I might need to add in here, where while we are if let's say this part where we okay. Yeah, so let's try submitting this solution. I have made the corrections. As you can see, the solution gets submitted, and time and space complexity of such solutions is n square, as we need to iterate over each of the square in this board. So it would be n square at the minimum. So if you found this video helpful, please like and subscribe to my channel. Thank you.